Hello, Dr. Okay, good afternoon. My name is Dr. Julius Eige, and I'll be with you for the next 3 hours. I'll be teaching a topic called mathematical induction, and I'll just wait for some of your colleagues to join, and by 2:05 we start this class. Thank you.
Sir, the Zoom participants is already full, 300, so I don't think anyone else can join.
Yes, but okay, that's true. Okay, okay. So today's class and today's topic is mathematical induction, and I will like you to.
Sir, is there no YouTube link?
Yeah, there's YouTube. I think there's YouTube.
Sir, can you share it so
Okay.
we can share it to our classmates?
Okay. Just give me a moment. Please check your platform. I think the YouTube link has been shared to your platform.
Which of the platforms, sir?
The 100-level platform. The subject. I think it has been shared. Okay, so I just start my topic for today, which is mathematical induction. And mathematical induction is a method of proof. It's a method of proof for proving statements in mathematics that involves discrete numbers or natural numbers. So these are like mathematical statements, and you use mathematical induction to try to prove these statements and deduce that these statements are actually true. So I don't know if you must have seen some formulas that they use for adding natural numbers. Such formulas, for example, like 1 plus 2 plus 3 plus 4, up to any particular number. And you can use that to, they give you a formula that you use to enter this, to calculate this sum. So I'm sharing my board now. I'm going to be writing throughout this class, and I'm going to just illustrate for you what mathematical induction is used for. So, for example, I know you must have seen formulas like this, maybe 1 plus 2 plus 3 plus... Can you see my screen?
No.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
You can see.
Yes, sir.
Yes, sir.
Yes, sir.
Have you seen formulas like this before?
Yes.
Yes.
Yes, sir.
Oh, okay, good. So if you have seen formulas like this before, right?
So please make it bigger.
And you are asked to maybe show that this particular formula is correct. So those are the things that we are going to be doing today. Okay, so let me just quickly stop this and just show you something about this course. So if, for example, I give you just a moment and I say, I want to show you a video. I want to show you a video. So just a moment. And I say, I want to share this video to you guys. So let me just share my screen, I think. So I'll just share my screen. Okay. So can you see my screen now?
Yes, sir.
Yes, sir.
Yes, sir.
I'll start the video
Yes, sir.
again.
Yes, sir.
Yes, sir. Yes, sir.
So you see that you must have seen a video like this before, where you start from 1, and by the time you toss that card, right, you see that it just follows. Just watch. So you see, it follows up to something and it continues like that till it gets to the end. So
Yes, sir.
this is the kind of principle we are going to be doing today. Something like this.
Yes, sir.
Yes, sir.
Okay, so
Yes, sir. You understand, sir?
so we're going to be using this technique today to solve some problems. Okay, so we are going to consider some who's what do you call it? Somebody is using a phone and a laptop or something. That's why it's so I'll just mute everybody. Please don't put on your speakers again so that we can all hear and there won't be distractions. Okay, so I'll now explain what mathematical induction is. So mathematical induction helps us to be able to, show formulas like this. There are so many of them. And that one is 1 square plus 2 square plus 3 square plus n square equal to n into n plus 1 times 2n plus 1 over 6. How are we sure this is correct? So that's the question. How do we establish that this particular formula that is given is correct? That if I choose a number, for example, I say I want to calculate 1 square plus 1 square plus 2 square plus 3 square up to 4 square. This will give me 1 plus 4 plus 9 plus 16, right? And everything here gives me 30. How am I sure that if I use this formula here, when n equal to 4, how am I sure that I'm going to get 30? So if you put 4 there, you get 4 times 5 times 9 over 6, right? And this gives me 2 here, 2 here, 3 here, 3 here, and this gives me 30. Okay, so you can see that this formula, is correct for the sum of 1 square plus 2 square up to 4 square. But the question is, if somebody tells you that the formula that adds up numbers from 1 square up to 20 square is 20 times 21 plus 41 over 6. How are you going to believe that person? So these are the things that we are going to establish today by using the principle of mathematical induction. Okay, so I'm going to write the theorem for you, and a theorem is a statement of fact, or statement of fact in mathematics that requires a proof. So I'm going to write the theorem without a proof. Then I will now go on to solve some questions on mathematical induction for you. So what is the theorem now? So theorem. Let P of n be an assertion or a statement involving a positive integer n. Then if P of 1 is true, if P of 1 is true, and for each k greater than or equal to 1, the truth of P of k.
So we can't hear you.
P of k plus 1.
Sir, we
Then
don't understand.
So we can't hear you.
I'm just
This is
writing
right.
a theorem. I'm just
I
writing a
don't hear
theorem. I'm going to explain after writing the theorem. Okay, just this is just a theorem.
Okay, sir.
All positive integer. Okay, so I'm going to explain now. So this is the theorem. The theorem says, let P of n be an assertion or a statement involving a positive integer n. Then, so don't forget, P of n is an assertion. So something like this, for example. Okay, you see that is a function of n. So P of n is like P, like f of, that's like the way you know f of x. You know, when you write f of x, you say f of x. You now write the right-hand side as different mathematical expression involving x. So this time around, we have let P of n be an assertion or a statement involving a positive integer n. So that's how the question comes. It's saying if P of 1 is true, and for each k greater than 1, greater than or equal to 1, the truth of k implies the truth of P of k plus 1. Okay, so what does it mean? It means that if I have a statement and I say this statement works for everything, right? I can try to tell you that it is true for 1, that's easy, or for several numbers I can count. For finite numbers I can count. For example, I've just done for you from 1 to 4 here, right? But how it works is that if I can establish that it is true for k, right, then the next thing for me is to show that it is true for k plus 1. Once that is established, then it is true for all n. Okay, I'll come again. I first of all show that it is true for 1 or for some finite numbers, maybe k greater than or equal to 1. Then the next thing I'm going to do is I just assume, for example, that it is true for k, right? Then I use that to show that it is true for k plus 1. Once I can show that it is true for k plus 1, then it is going to be true for all n. Okay, so the summary of this proof, I'll write it for you now. So the summary of the proof. I'm going to clear my screen now. So what I'm going to do now is now to summarize that proof for you so that you see what I'm talking about. Okay, so the summary of the proof now. So I'm coming down here to write the summary of the proof. So, and this summary of the proof is what will guide us to prove all the mathematical statements we are going to use in class today. Okay, so number one, the summary of the proof. So I write how to prove by mathematical induction. The first thing you do, you show that it is true for n equal to 1. That's the first thing we are going to show. Okay? Number two, we assume that it is true for n equal to k. Okay? The last part is to show or deduce that it is true for n equal to k plus 1. Okay? So I call it or show or proof also. So the rule is like this, SAP. Okay? I show the first one, right? I assume the second one, then the last one I prove. So maybe I should use proof here so that you can always see the P. So I just call this proof. Instead of showing, I say proof. Okay? So SAP.
Yes.
So the first one, I am going to show it is true for n equal to 1. Don't forget, the second one, we assume it is true for n equal to k. Okay? Then lastly, we must prove that it is true for n equal to k plus 1. Once we have established these three, then the deduction means that what? It is true for all n. It is true for all n. Okay? So that's what we're going to do. Okay? Don't forget, this should become handy for you because that's what I'm going to be repeating for all the questions that we're going to be solving today. It's very interesting, and you see that it is very interesting to do. Okay? So I'm going to stop sharing. I'll come back again because I want to remove this caption that I have here. I'll stop sharing and I'll come back again. Just a moment. Stop sharing. I want to stop my caption. I share again. Share my screen. Okay, then I'll come here. Then I will share this. Okay, we're back. Now I'm going to give some questions that we want to solve. Well, we start from the very simple ones that we make us understand and learn the theory. Okay, so I will save this, then clear my screen. So I want to clear everything. Okay, so the first one we want to solve now. So we want to show, number one, examples. We want to show that 1 plus 2 plus 3 plus n equal to n into n plus 1 over 2. We want to show this. Okay? So, using our principle, don't forget, what's our principle? Who can remind me our principle? What's our principle? SAP. Okay? SAP.
SAP.
Okay.
SAP.
Good. SAP. Okay, so the first one I'm going to do is to show that it is true for n equal to 1. What does that mean? That means that if I start from this point and I put 1 here, 1 is the left-hand side. Okay? The right-hand side is just for me to put n equal to 1. So that will be 1 into 1 plus 1 over 2. And this is 2 over 2, which is equal to 1. So this is true for n equal to 1. In fact, I can still show that it is true. This n I wrote equal to 1 here. You can still show for maybe 3 steps, maybe 2 or maybe 1, 2, 3, if you like. But I always show for 1. So you can also try to show for 2. So you can say, okay, 2, LHS for 2 will be what? Sorry, for 2 will be 1 plus 2, sorry. 1 plus 2. So 1 plus 2, left-hand side. Right-hand side will be what? 2 into 2 plus 1 over 2. This will give me 2 times 3 over 2. This cuts and I have 3. So 3 equal to 3. So it's also right. Okay? So these two parts I have done now, right? I've been able to what? To do the first part. Okay? So the second one now is what? Is assume. Number 2, SAP. Assume. So we have done S. Okay? So the next one is to assume. So we assume. Assume
That is true for n equals to k.
it is true. Abayomi, what's your question?
So why is it 1 plus 2 and not just 2 on the
So,
left-hand side?
because what we want to establish is 1 plus 2 plus 3 plus 4 plus 5 plus 6 up to plus like that 1,000 or something like that. So if I say 1 plus 2, that means I have 2, I've taken 2 steps. So I want to check the right hand side. If I put 2 there, will I get the same thing if I say 1 plus 2? That is what we are trying to do. Okay? So if I assume it is true for k, then that means that 1 plus 2 plus 3 plus 4 plus k, because I'm assuming it's true for k. Don't forget, I'm assuming. So if I assume it's true for k, then this will be equal to what? K into k plus 1 over 2. Because I assumed. I'm saying, okay, if this is the formula, let me just assume it's true for k. If it's assumed for, if it's true for k, if I assume it's true for k, then that means 1 plus 2 to any number k will give me k into k plus 1 over 2. Okay? Now, the third one is the P part. Now I want to prove that it is true for n
wait,
equal to k plus 1. Yes.
sir, please wait. Sir, please, I don't understand this. I've been confused, like, just
How?
before the example. I've been confused from before the example. I'm just confused. Please, can you
You are not
explain?
here before.
So
Yes, I was
what,
on YouTube.
so what I'm trying to
Ah,
do is
oh my God.
to try to, I want to try to save some time. So you have to listen to me very well. So we are trying to use a rule that we call SAP. Okay? The rule says SAP.
Okay, sir.
So that rule says the first one is that we show it is true for n equal to 1. That's what we have shown here. So we just take 1 from the left-hand side and put 1 into 1 plus 1 over 2, and that gives me 1. So 1 and 1 is correct. Okay? If I tried for 2, 1 plus 2 on the left-hand side. If I put 2 here, 2 into 2 plus 1 over 2 gives me, 2 times 3 over 2, and that gives me 3. So 1 plus 2 gives me 3. The formula also gives me 3. So that shows that it's right. So the next thing I want to do now is to assume that it is true for n equal to k, and I have done that. I'm saying that 1 plus 2 plus 3 plus k equal to what? K into k plus 1, because I have assumed that this formula is true for k. Okay? Now, which is what I've done. Now, the third one is now, I want to prove that it is true for n equal to k plus 1. Okay, how do I show this? That means I must show that if I do this, right? This must give me k plus 1 into k plus 1 all over 2. That's what I must show. Okay? Because if I put, I'm going from 1 to k, I've assumed it's true for k. If I say I'm going from 1 plus 2 plus 3 to k plus 1, that means if I put this k plus 1, if I put it inside this guy here, right? My n here will be what? K plus 1, right? My n here too will be what? K plus 1 plus 1 over 2, right?
Yeah.
This is what I get. But how do I show
Why
that?
show that this
Please mute
is
everybody. Please mute yourself. So how do I show that this guy here, this guy I have here now, actually gives me this thing I have here? K plus 1, k plus 2, all over 2. This thing I've written now, I have simplified it to k plus 1. 1 plus 1 gives me 2. So how do I show that this guy here gives me this? This is the trick. Don't forget that I've already assumed that 1 plus 2 plus 3 plus dot up to k gives me this, right? But this thing I have here, this guy I have here, right, is the same thing as 1 plus 2 plus 3 plus up to k plus k plus 1 is just the next thing after k. Do you agree with me?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Now that you agree with me, since we have assumed this guy, we have assumed this guy now, right? As what? K into k plus 1, right? Over 2. Okay? If I add k plus 1 to it, k plus 1. Right? Right? K plus 1 is common to these guys. What will I have? I will have k plus 1 into what? K over 2 plus 1. Right? And if I take the LCM of that, right? What will I get? 2 here, I have k plus 1 here is 2, and this gives me 2, which gives me what? K plus 1, k plus 2 over 2. I have been able to establish that these two are the same. And because of this, then it is true for all n. Close, case close. Question, your question. Your question.
Okay, sir. So you gave
Yeah,
us
okay.
a theorem before we got to this example.
Yes, I gave us what? I gave you what?
A theorem.
Yes.
Yeah, so are we doing all of this on the basis of that theorem? Or
Yes. We are doing this based on the basis of that theorem. And I've summarized that theorem for you as SAP.
Okay.
SAP show that it is true for n equal to 1, okay?
Okay.
You assume that it is true for n equal to k, right? And number 3, you prove that it is true for n equal to k plus 1. Is that clear?
Yes, sir.
Okay, so I am going to take another example now, before I will now ask somebody to try to do something for us in class, okay? The next example I'm going to try, covenant.
Excuse me, sir.
Covenant, your question.
Sir, please can you recap the third summary?
Okay, so before I go for the next question, let me use this one to explain again, because it's quite the simplest that we know, okay?
Sir, please, I've been raising my hand.
I said I'm going to go. Your question will be inside the explanation. So let me go again from the beginning, okay? All right. So the truth is that you want to use SAP, S for show, A for assume, P for proof. Okay? So the first one, I want to show that it is true for n equal to 1. Okay? So what is the first statement here? If I pick the first step here, it is 1. Everybody, please put your hands down. I'm explaining. All your questions will come will be answered in my explanation. I'm starting from the beginning again. So just drop your hands. Don't worry. Okay. So left-hand side, 1. equal to, I put 1 in the formula, that will be 1 into 1 plus 1 over 2 gives me 2 over 2, which is 1. Okay? I did overskill. I went to go and do for 2 for n equal to 2, right? And I said 1 plus 2 on the left-hand side. We want to check if the formula actually gives us 1 plus 2 is 3. So we want to check the formula. If I put 2 in the formula, after taking 2 steps, right? Will I get 3? So I put 2 there, and I put that becomes 2 into 2 plus 1 over 2, and that gives me 2 over 2 times 3. And if 2 cuts itself, then I have 3 left. Okay? Which is true. Now, using the SAP statement, A says you should assume it is true for n equal to k. So whether it is correct or it is not, whether it is correct or not correct, you just want to assume that it is correct. So it's like a guesswork. Suppose it is correct for k. And that's how you do for everything that you're trying to prove in mathematical induction. So we just try to prove. Okay, so n equal to 2 plus 3 plus up to k should normally, if it is true, it means anywhere I see n in the formula that was given to me, anywhere I see n, then I change it to k because it is true for k too. Okay? K means k is standing for any number, like could be 1,000, could be 1 million, but just k. Okay? Then if it is true for k, then that means that this n into n plus 1 over 2 becomes k into k plus 1 over 2. Okay? Right? So we have assumed that it is true for k. Now, the last one, which is P, SAP, P means to prove that it is true for n equal to k plus 1. How do we show this? We can only show this by summing the left-hand side up to k plus 1, right? And to show that if we sum the left-hand side up to k plus 1, right, then we must get k into k plus 1 into k plus 1 over 2. That is putting k plus 1 in the formula that was given to me, because this is a question. So if this is k plus 1, what are we expected to get if we do that? We are expected to get k plus 1 here, k plus 1 here, and that makes this particular bracket here make k plus 2, okay? And that's how I got k plus 2 here. So we want to show now that this left-hand side actually gives me this. We have not shown that. We have only used the formula to establish what k plus 1 will be, but we have not shown it. But how do we show it? We will show it by starting our sum from 1 to k plus 1, but we must take our assumption that we already know, because we already know this previous one. We already know this guy. From 1 to k, we already know by our assumption. And our assumption is that 1 plus 2 plus 3 up to k is k into k plus 1 over 2. Okay? So if I put that here, which is k into k plus 1 over 2, plus the k plus 1 that was added recently, right? Then this sum we have here, we must show that this sum gives us this guy. If the sum does not give this guy, then it is not, then the proof is not correct. Okay? So what do we do to show this sum? This term and this term, right? K plus 1 and k plus 1 is common to both. So I factorize k plus 1. And if you factorize k plus 1 from both, what is left here is k over 2, right? If I remove k plus 1 from here, what is left is 1. Okay? Then I take the LCM here and try to simplify it. And I will have k plus 1 multiplying k plus 2 over 2. And because I've been able to establish these two guys, that the sum up to k plus 1 gives me the sum when I put k plus 1 in the formula, then I can conclude and deduce that it is true for all n. Okay? All right. Example 2. Example 2. Example 2, I want to show the second one. 1 plus 3 plus 5 plus 2n minus 1. Sorry. Equal to n squared. Okay, I want to show this. So I'm going to start the proof using our rule. What's our rule? Who can tell me our rule?
Stop.
Stop. Good.
Stop, man. Stop.
Stop.
Stop, Andre. Stop.
We know.
Stop.
Sapa.
So the first one, SAP. So I prove okay. So 1 on the left-hand side, right? On the right-hand side, 1 square is equal to 1. So it is right. Okay? Maybe I just try to go further so that you can appreciate the formula. So for 2, sorry, don't be annoyed, sorry. For 2 now, we'll be taking 2 steps. 1 plus 3 on the left-hand side, okay? If I come to the right-hand side, 2 square gives me 4. 1 plus 3 gives me 4, right? So this is also right for both of them. So I'm going 2 steps. If I put 2 here, then I have 4. Okay? Now I'm going to move to the next one. So this is number 1. Number 2, I will assume now it is true for n equal to k. What does that mean? That means that if I say 1 plus 3 plus 5 up to 2k minus 1, right? This must give me what? K squared. Okay? Because if I say it is true for k, right? Then if I sum everything up to 2k minus 1, then I must get k squared. I'm assuming. Okay? Number 3. Now I want to prove that it is true for n equal to k plus 1.
Sir, please can you also prove that 1 plus 3 plus 5 equals to n squared? Like for the number 5 there.
You say, can I also prove 1 plus 3 plus 5, right?
Yes, sir.
Let me do it.
Without
Let me do it here. Let me do 1 plus 3 plus 5 equal to 3 squared. 1 plus 3 is 4. 4 plus 5 is 9.
Yes, sir.
Right? So 3 squared is 9. So that's correct. Okay?
Yes, sir.
Okay, so now I want to prove that it is true for n equal to k plus 1. Okay? So now it will be what? 1 plus 3 plus 5 plus, don't forget, I want to prove when n equal to k plus 1. 2k plus 1. I want to show that this will give me k plus 1 squared. Okay? Because if I
What about the minus 1?
Minus 1, yes.
no, I'm going to k plus 1 now. So I'm doing 1 plus 2 plus 3 up to k plus. So if I put k plus 1 here, that will be 2 into k plus 1 minus 1. That's 2k plus 2 minus 1, which is 2k plus 1. Is that clear?
No. Yes.
Yes, sir.
No.
Okay, so
No,
No.
it's not clear. Okay, don't worry. It's okay. It's okay. It's okay.
It's not clear.
So I'm going to 2k plus 1. So that will be 2 into k plus 1 minus 1. Okay?
Yes.
Okay, so this will be 1 plus 3 plus 5 plus 2 into, no, sorry, 2k. I'm expanding now.
Yes.
So this will be 2k plus 2 minus 1, right?
Oh, yeah.
Equal to k plus 1 squared. Okay? 2 minus 1 is what? What's 2 minus 1?
1.
Okay, 1. So this just becomes 1. Okay? So we now want to show that this guy, right, gives me this. We are not sure. We are not sure yet. We only know by the formula that if we put k plus 1 there, if we put k plus 1 here, we will get k plus 1 squared. But we don't know that if we add from 1 to 2k plus 1, we will get it. We don't know yet. The only thing we know now is what I'm going to write on the board. The only thing we know is that if we have this guy, 2k minus 1 plus 2k plus 1, we only know this guy. We only know this part. Because, you know, look at this. Look at this. This first term is 1. When n equal, so let me start. Let me do this. From here, look at this. When n equal to 1, right? 2 times 1 minus 1, that's this guy. When n equal to 2, right? That's 4 minus 1, that's 3. When n equal to 3, 2 times 3, that's 6 minus 1, that's 5. When n equal to k, right? That's 2k plus 1. Yeah, sorry, 2k minus 1, that's this guy. Okay? Now, when n equal to k plus 1, that's what we have added to this now. We have added it to it. Okay? That's this guy. Okay?
But the difference between the first and the second term is 2.
Yes, now it has to be 2 because the difference between 1 and 3 is also 2. The difference between each of them are 2 now. So each of them, the difference 2 will be 2. This one is, we are stopping at k here. But for the last one that we're trying to prove, we will get to k plus 1.
Okay, sir.
Yes, okay. So we already assume this guy, right? And what's the assumption of this guy? The assumption of this guy is that at k is this guy, is k squared. Okay? Okay? So that means that this guy I have underlined here is what? Is k squared plus, what's left?
2k plus 1.
Plus 1.
K plus 1 square.
Okay?
Yes, sir.
A very smart student would have seen that this guy is the same as what? K plus
A
1.
plus 1.
So since we obtain,
it's k squared plus 2k plus 2, not 2k plus 1.
where do you get 2? Where do you get 2k plus 2? Where do you get 2k plus 2?
No, you not subtract it.
See now, see. Expand
Yes, I've
this.
seen it. I'm sorry, it was my mistake.
Okay, good. So since we obtain k plus 1 square, implies that we have proof for what? For pk plus 1, right? And this means that true for all n. Okay. Samuel, what is your question?
Sir,
Yes.
my question is the left hand in this example, does the left hand side, the summation of the left hand side have to be, does it have to be like the right hand side has to be a perfect square of the summation of the left hand side?
No, you should not be bothered with what the formula is, whether perfect square or property. They will give you a formula like this and ask you to prove induction. Yours is to use SAP. You show it is true for n equal to 1. You assume it is true for n equal to k, and you prove that it is true for n equal to k plus 1. These formulas, there are many. We are going to do a lot now. Don't worry. We are going to do several types. So there are some that does not even have square at all.
Yes, sir.
So just your own is just wait for the question, right? Understand the concept and apply it.
Yes,
okay,
sir.
and that's what I'm trying to explain.
Thank you, sir.
Robert Blessing, what's your question?
How do you get k squared plus 2k plus 1? The left hand side.
This one? This one? I can't hear you. This one?
Yes, sir.
Yes, sir.
Okay. Look up. We have assumed, look at this now. We have assumed here that this is true. This is true for, we have assumed that it is true for n equal to k, right?
Right, yes.
So since we have assumed that it's true for n equal to k, you know that, you see, what you must understand is that, let me clean this so that I will do something for you. What you are adding, just a moment, please. What you are adding is, you're adding this one you have here, this one here is when n equal to 1. This one when n equal to 2. This one when n equal to 3. You are continuing to add when n equal to k. This one is when n equal to k plus 1. You see that? You see that? So when you are adding, you have already assumed that when n equal to k, when n equal to k, the answer is k squared. That is all these guys.
Yes, sir.
Okay. Now to show that it is true for n equal to k plus 1, that means you want to add from 1, 2, 3 to k plus 1, because k is before k plus 1. But you know, I could have just written 1 plus 3 plus 5 up to 2k plus 1. But this 2k minus 1 will be hidden inside. So I'm writing it out so that you can see it, because we have already assumed I cannot use the formula for the assumption of 1 to 2k minus 1, which is k squared that we have. That's this guy.
Okay, yes, sir.
So this guy is just what is left, because we already know these guys at the back. And
Yes,
this guy these guys that we already know here, right, is this k squared that is here. You see, it's just the same formula. Look at it here. This is it here. It's the same thing. So I replace all these guys for k squared, right? Then I now add the 2k plus 1 to this guy. Of course, everybody knows that this is the same thing as k plus 1 squared.
Yes, sir. Yes, sir.
All right. Can we take another example?
Yes, sir.
Yes, sir.
Yes, sir.
Sorry.
Let us try this example. 1 square exercise.
Sir.
Written down from our own.
I have a question.
Exercise 1 square plus 2 square plus 3 square plus n square equal to n into n plus 1 2n plus 1 over 6. This one is quite complicated. This one is quite complicated, but it's just they are all very simple. They are all simplifications. Okay, let's try to. Okay, so I'm going to use the rule now. SAP. So the first one, number 1, I'm going to show it is true for n equal to 1. Okay, so 1 square will give me 1 into 2 multiplied by 3 over 6, and that gives me 1. Okay, so that's 1 square here is 1, right? Now this place, if I put n equal to 1, I have 1 times 1 plus 1 is 2. 2 times 1 plus 1 is 3. Okay, if I do that, I get 1. Okay, so n equal to 2, just to be sure that it is correct. Okay, 1 square plus 2 square. This should give me 5. Okay, this should give me 5. So I'm going to put that in the formula now. Put n equal to 2 in the formula. That will give me that will give me 2 times 2 plus 1, which is 3. Then 4 plus 1, which is 5, right? Over 6, right?
Sir, please.
Right?
Yes.
So this guy here is 6, and I have 5. Okay, so 1 plus 4 is equal to 5. So that means the formula is quite right, but let's just check. Okay? Yes. So the next thing I'm going to do is to assume that it is true for n equal to k. Okay? So to assume it is true for n equal to k, right?
Yes.
And that will give me 1 square plus 2 square plus 3 square plus k square. If I assume, then it means this must be correct like this.
K plus 1.
Because I'm just using the formula that I'm giving, even though I don't know if it's right or not. I'm just assuming it is right. Okay? So the next thing I want to show now is I want to show it is true for what? N equal to k plus 1. Okay, so 3. To prove that it is true for n equal to what? K plus 1. So that will be what?
Progress.
So that will be what? You people keep unmuting yourself. So 1 square plus 2 square plus 3 square up to what? K plus 1 square, right?
Yes, sir.
Yes.
I want to show, right? I want to show that this sum here will give me what? K plus 1 into k plus 2
Plus 1 plus 1.
into
Yes.
2k plus 3.
Yes, sir.
I want to show this. Okay? that if I add this guy, right, it should give me this formula when my n equal to what? K plus 1. That's what I want to show. Okay?
Yep.
So how do I do that? I'll come by writing 1 square plus 2 square plus 3 square. Before a k plus 1, there was a k. Is that not correct?
Yes,
Before
sir.
a k plus 1, there was a k.
Yes, sir.
Yes, sir.
So, but we know this guy already. We know this guy.
Okay,
We know
yes.
this guy.
Yes.
By what? By our
Okay.
assumption,
Yeah.
Yes, sir.
right? What's our assumption? K
K into bracket K plus 1
K plus 1
into bracket 2K plus 1 over 6.
over 6 plus what? Plus k plus 1.
2K
Okay.
plus 1. Yeah.
Is this the same thing as this guy here? Is it the same? That's the question to ask.
That one I want to prove.
If we can show or simplify that and get this, then we have been able to show that it will be true for all n. Okay? So how do I do that? Quickly, I'm going to show that now. So something is common to both of them. What is common to both of them? K plus 1 is common. So
Yes, sir.
Yeah.
We bring it out as K.
So k plus 1 is common,
K plus 1.
right?
Yes, sir.
What is left?
K
K
into bracket 2K plus 1 over
right?
6.
Over 6, right?
Yes, plus K plus 1.
I like you guys. You guys are very smart.
Yes, sir.
I like smart students. You guys are very, in fact, everybody will get A in this course.
Yeah.
Everybody will get A in this course.
Yeah, yes.
So this will be k plus 1, right?
Yes. Yes, sir.
So I take the LCM now, right?
Yes.
6 is the LCM.
6.
2k plus 2k square, right?
Yes, sir. Plus K.
Plus k, right?
Yes.
1 here is 6.
That's 6.
6K
6K
plus
plus.
Right?
Yeah, that's 6K plus 6.
So this is k plus 1 into bracket 2k plus 1.
2K plus 1.
Sorry, 2k
2K
square
square.
plus 7k plus 6
Yes, yes.
over 6, right?
Yes.
Okay.
Something like this. Okay?
Yes. Yes, sir.
So we want to show now, right,
Yes, sir.
that this guy we have here, right,
Yeah.
is this guy.
Sure.
That's what I want to show, right?
Yes, sir.
How do we show
Yes,
that?
sir.
2 times 6 is 12. So what's common? 4 times 3, right?
Yeah.
K plus 1 into 2k plus 2 plus 4k plus 3k plus 6 over 6, right?
Yeah.
Simisola, your hands have been up. Please, can you ask your question?
Start from number 3, I'm confused. Start from number 3.
Okay, number 3, Abby. Number 3, right? Okay, start from here. Okay, I want to prove that it is true for n equal to k plus 1.
Okay.
Okay?
Yes, sir.
So let me quickly hear from Ashinze. Let me know if the questions are tied together. Ashinze, your question.
Okay. Now my question is, from the beginning, you know, we are talking about n.
You said?
There isn't any difference. Like from the beginning, you were like, let's n equal to 1.
Ashinze, please, can you try to speak louder so that we can all hear your question?
I said, sir, from the beginning, you were saying that n is equal, like we should let n equal to 1.
N is what?
You said we should let n be equal to 1.
I'm struggling to hear you, my friend.
I said, from the beginning, you were saying that we should let our n equal to 1.
Yes.
Yes. So what I'm saying is that, like, the first time you use n as the like final value, for the second time you use n as the number of values we're working with. In this particular context, does n actually have a particular like value is attached to it, or n depends on the equation that is coming with?
So what you see, this n is just a determinant. This n here, right, is just a variable here to determine where your sum stops. The number of steps you are counting.
The number of steps you are counting.
Okay, that's what the n implies. So if I say if I want to take 10 sums now from 1 to 10, the next 10 sums, then the right hand side n has to be 10. But in the left hand side, it will be 1 square plus 2 square up to 10 square. I guess that answers your question. Okay, so let's go back to the question the other lady asked of. So we want to prove that n equal to k plus 1. Okay, that means that we must take the sum from 1 square, 2 square, 3 square, up to k plus 1 square. Okay, but the sum from 1, 2, 3 up to k plus 1, there's a k here, because you can see this dot, dot, dot means and so on. It means you have skipped so many numbers. K is in between. K is inside.
Okay.
Okay, so that's this k now. So this k is the number just before k plus 1. You know, if you're adding 1 for natural numbers, if I say, if I'm in 100, the number before 100 will be 99. So that's what this k is representing. Okay? Any dot, dot, dot you see here means and so on. That means I don't want to write so many things, but there are so many things in between these 3 dots. But the numbers are, don't forget, the numbers are what? Are sequential. Sequence of natural numbers, not real numbers, but natural numbers. 1, 2, 3, or counting numbers, like we used to say, counting numbers. Okay, so if you do that, because we already know the sum from 1 to k plus 1 to k square from our assumption that we have here, that if we put k square, we have this. I just substitute this guy. You see this guy here now, right? It's going to be substituted for this guy, all this sum. You see, I just substituted them for this sum.
Okay.
But if I substitute these guys up to k square for this sum, right? I still have k plus 1 left. K plus 1 square left, which is this guy. So it means this sum that we already know from k square plus this k plus 1 that is left. So we're not going to add the two to be sure that if we add the two, will we get this guy here? This guy, will we get it? Because this is what we are working towards for this formula when n equal to k plus 1. Okay?
Okay, sir.
So we now factorize k plus 1 out, and we arrived at this guy, and we simplified to this form. We took the LCM, we got this, and we had a numerator that looks like this. And for us to conclude our proof, we have to factorize this numerator. So you have a constant a, and you have a constant 6. So for you to be able to do that, you have to multiply 2 times 6, you get 12. You look for the two numbers that if you multiply, you get 12. And if you add, you get 7. Okay? And that's what I've done. Okay, so this will give you what? K plus 1 into 2k into k plus 2 plus 3 into k plus 2 over 6. Right? Right?
Yes, sir. Yes.
Then the next thing is that I have k plus 1 out here, which is this guy. What is common to this equation? What is common? K plus 2 is common. Right? What is left? 2k is left. What's the second one? What's left? 3.
3.
So since we have proved this, it is the same. Okay? Then we say it is what? It is true for all n.
Of n.
Asan, Oluwatobi, a question.
So something to ask that. Sir.
Yes, I'm with you. I'm with you.
So I wanted to ask that this thing, what do you always call it? What we are working towards, that k plus 1 bracket, k plus 2 bracket, k 2k plus 3 all over 6.
Yes.
Like, how do we get that equation that we're working towards?
Oh, this one here. Just we are working towards. You have a formula already now. This is your formula. So just put k plus 1. Put k plus 1 here. You get that?
Yes, sir.
K plus 1 here.
Yes, sir.
Put k plus 1 here.
Assume.
And you get this.
N equals to k plus 1.
O when. Your
Good afternoon,
question?
sir.
Yes.
Sir, can you please give us an example where the answers at the end are not the same?
Where the answers are not the same. Okay. Let me. I'll try. I'll try to form something now.
As in, we're not able to prove it.
Yes, I'm not able to prove. Yes, I'll try to form something now.
Yeah, something like that.
Yes. Let me look for. I'll look for a very simple one for that. In fact, that's good. Okay.
Okay, sir.
Thank you, sir.
So the next example now. No, don't write this in your note as example. I want to explain to what that guy asked. Okay. So not correct. Let's do this. Not correct. So we want to prove that. Let me see. That A B raised to power n equal to an B raised to power n plus 1. I want to prove this formula using mathematical induction. Okay? So what it means is that for n equal to 1, that will be A, B raised to power 1, right?
Yes.
Which is the same thing as A times B, right?
Yes.
But the right-hand side will give me what? A1 dot B2, right? This is not right. You see, it's not right for n equal to 1. My friend.
Yes, it's not right.
It's not right.
So I'm going to approve the second one, sir.
The second one. Oh, okay. What do you so I assume?
Yeah,
I assume
that
assume it is true for n equal to k. So I say A raised to power B raised to power k, right? I'm assuming that A raised to power B is the same thing as what? A raised to power k equal to B raised to power k plus 1. Okay. So I now want to show that AB
Sir, it's not equal to dot.
is not equal to, right? It's not equal to. No, I'm assuming it will be equal to. I'm assuming.
We're assuming it's equal to.
So he's saying I should apply the rule. Okay. If I assume, it's not true for 1, I want to assume that it is true for k. Okay. So if I have A this, I want to show that k plus 1, right? Right? Which is the same thing as A B of k dot A B, right? Must give me the formula AK plus 1 plus BK plus 2. Okay? But is this true? We want to see now if it's true. This one will give me A B K dot AB, which is AK plus 1 plus BK plus 1.
K plus 2.
As AK plus 1 plus BK plus 1 plus BK plus 2. This is not correct.
Not correct.
Okay?
Okay, sir.
It's not working.
Yes.
So that is, I'm not going to put this in my notes, but I'm just to show you that it won't work. Okay?
Okay, sir. Thank you very much.
Oh, I already put in my note to why? Okay, I'm going to delete it. But I'll delete it. Okay, no problem. Now let's take another example. Another quick example. Let us see this thing does not only work for equations, it can also work for what they call it, for statements. So let's try number 4 exercise. We want to show that 3 raised to power n minus 1 is divisible by 2. So it means that if I say 3 raised to power 1 million minus 1, if you divide it on the calculator, you will not get any remainder. That's what I'm saying. Well, how can you know? If you don't try it out.
You suck.
So we want to use mathematical induction to show you that 3 raised to power n, any natural number or counting number. If I put any natural number or counting number there and I take 3 raised to power that number and I subtract 1 from it, that number must be even. That's what I'm trying to show. Okay? So how do we do this? So I'm going to use what? SAP. So number 1, I'll just try to quickly show that it is true for n equal to 1. So we want to show it is true for n equal to 1. Okay? And this implies that 3 raised to power 1 minus 1 is what? 3 minus 1, which is equal to 2. Of course, 2 is divisible by 2. Is that correct? Because I'll get remainder 1.
Yes, sir.
Because, in fact, before I start this proof, don't write yet. Let me just write something. A number is divisible by 2 if a number m, let me write this, a number m is divisible by if m can be expressed as 2 raised to power n. Okay? Where n is the set of all natural numbers. Okay? So once I can express that number as 2 times something, then I say that that number is what? Is divisible by 2. Okay? So we start. Number 1. So I want to show that it is true for n equal to 1. Okay? So that will be what? 3 raised to power 1 minus 1. And that gives me what? 3 minus 1, which is what? 2. Which is same as what? 2 not 1. Okay? So because I can express 2 as 2 times 1, then I can say it is what? It is true. Okay? Number 2 now. I want to assume that it is true. For what? N equal to k. So what does that mean? This implies that 3 raised to power k minus 1, right?
Yes, sir.
Is equal to what? 2 multiplied by a particular number. Let's give that number. Let's call that number maybe k, for example. Or let me just call it nk. Let me call it
X.
K. Or let me call it, okay, let's call it X, my friend. Okay,
Yes.
my friend said X. Let's use X because we're in a math class. Okay? So let's put that X. Okay? Now we want to show now, okay? Number 3, proof. That's the P part. We want to prove that it is true for what? N equal to k plus 1. How do we show this? How do we show this? That means we want to show that 3k plus 1. No, let me write this in statement so that it will be very clear. That is, we want to show that what? 3k plus 1 minus 1, right? Will be equal to 2 times a certain number, maybe x plus 1 or something. Okay? Because x was for k, maybe x plus 1 for k plus 1 or something. Or we want to show that maybe let's don't assume that we even know it's x plus 1. Maybe y, for example. We want to show that it is 2 times a particular number, for example. We want to show that this we also be able to write this as something like this, because that's our definition from the beginning. That we must be able to write these 3 into k, 3 raised to power k plus 1 minus 1 as a multiple of 2. That's what we want to try to show. Okay? So how do we show this? This 3k plus 1 we have here is the same thing as what? 3 raised to power k times 3. Do you agree with me?
Yes, sir.
Do you agree?
Yes, sir.
Yes,
You
sir.
agree with me?
We agree with you.
So if you agree with me, since we have already assumed that 3k, this formula is true for n equal to k, right? Then 3k plus 1 at any point will be what? 2x plus 1. Do you agree with me?
Yes, sir. Yes.
Do you agree with me?
Yes, sir.
Good.
No, sir.
Then
Sir,
this
please,
No.
yes,
Please
yes.
come again.
Please come again.
Okay. So I will
Come
start again
again.
like this.
I agree.
So I'm assuming that it's true for 1, which we have agreed. We're able to establish 2 as 2 times 1. Okay. We want to now assume that it is true for n equal to k. So we are saying that if it is true for n equal to k, that means that 3 raised to power any value that I have up to k minus 1 will give me 2 times something. That x, I don't know what that x is. Olamide, drop your hand. I'm explaining again. Okay. So we have now assumed that this is true for what? For k, right? Now we want to show that it is true for k plus 1. Okay. So to show that it is true for k plus 1, what do we do? It means that we want to show that 3 raised to power k plus 1 minus 1, right, will be equal to 2 times a certain number. We don't know what the number will be, but we want to be able to write it as 2 times a number. Say maybe y, for example. But we know that 3 raised to power k plus 1 can be written as what? 3 raised to power k multiplied by 3, just by indices. You know indices now? 3
Yes,
times
sir.
they share the same index. So we just say 3 into k plus 1 is this. Minus what? Minus 1. But this 3k we have here, from our assumption here, 3k is the same as what? 2x
plus 1.
Okay? Then I can substitute that.
2x plus 1.
Oh, sorry.
No, no.
3k.
2x plus 1 minus 1 will give us 2x, right?
So I have
2x
3
plus
into
1.
what? 2x plus 1, right?
Yeah.
Right? Minus 1. Okay? And that will be what? 6x
6x plus 3
plus 3,
minus
right? Minus 1, right? Which is what?
6x plus
6x plus what? Plus 2. And I can write this as what?
Confused.
Into bracket what? 3x plus what?
plus
1.
1.
You see, I've been able to write this particular value, this 3 into k plus 3x per k plus 1 minus 1, as a multiple of what? Of 2.
Nice.
I have
Yeah,
been
the
able to
multiple of 2.
express
Crazy.
as a multiple of 2 then it is true for n equal to k plus 1. What's our deduction now? Deduction. 3 raised to power n minus 1 is what? Is divisible
Sir, sorry, but I don't seem to understand from step 2. Step
from where?
2.
Yes, from
Step
step
2.
From step 2.
Okay, from step 2. From step 2, we want to assume that it is true for
How
what?
did you get 3k is equals to 2x plus 1?
Calm down, now that what is explaining.
Which one? This one? This one? This one?
Start from number 2, I beg.
Yes, sir. Yes, sir.
Let me start from number 2, please. Number 2. Number 2. Everybody, drop your hands. Drop your hands now. Unmute. Drop your hands now and mute your system. So we want to assume that it is true for n equal to k. So the assumption is that if it's true for n equal to k, just put k for 3, right? And we have 3 raised to power k minus 1, right? Must be equal to 2x, where this x is any number, any natural number. That is, we can express this guy as a multiple of 2, okay? As a multiple of 2, 2 times something. So my friend chose x as that number, okay? Now, if 3k minus 1 equal to 2x, then it means that 3k, this 3k can be 2x plus 1, because this one comes here. So I have a 2x plus 1. Okay, so anyway, I see 3k. I can use this 3k as 2x plus 1. Okay?
Oh, like terms.
So now I want to prove that it is true for n equal to k plus 1. Okay? So I put 3k plus 1 minus 1. I want to show that this guy is going to be a multiple of a value, say y, for example. Okay? And we are able to show at the end of the day that y was 3x plus 1. But I want to show you now. Okay? Now, this 3k plus 1, right, can be rewritten as 3 raised to power k multiplied by 3 minus 1 using the law of indices, you know, a raised to power b, sorry, a raised to power b times a raised to power c equal to a plus b plus c. That's what I've used, okay? So it means 3k plus 1 will be 3 times k times 3 raised to power 1, okay, which is 3, okay? Minus 1, that's this guy, okay? So anyway, I see this 3k now. I have now substituted this 3k with this 2x plus 1 that I wrote here, okay? If you take an expansion, 3 times 2x gives me 6x. 3 times 1 gives me 3, right? Then the minus 1 I have here is minus 1. And this gives me 6x plus 3 minus 1 gives me 2. And I am able to factor out 2 from this. If I factor out 2 from this, I have 2 multiplied by 3x plus 1. And I have been able to show that 3 into k plus 1 minus 1 is a multiple of 2. It's a multiple of 2. And since I've been able to show that, then my deduction will be that 3n minus 1 is divisible by 2.
So how do you get 2x plus 1?
How did I get
2x plus 1.
Factorized it.
I just did it now. So
Are you sure you're even listening?
3k minus 1 equal to 2x, because I'm showing that I want to show that this guy is I assume that this guy is divisible by 2. That means that I'm able to express this guy as 2 times a number. And that's what I've just done.
Okay,
Yeah,
sir, continue.
Sir,
Let me find another example. Okay. So I'm going to example now. Example. I want to show that 1 plus 5 plus 9 plus 4n minus 1. I want to show that this is 2n squared minus n. Maybe I allow you try this at home. Just try this now. Let me see who has a what they call it? Who has a stylus and can write on the screen here amongst you guys. Let me allow the person try to solve this for us.
Those that can solve should solve.
those that are what?
Aliyah, do you want to try to solve it for us?
Yes, sir. So everybody can try it now.
No, everybody can
You can
try it,
just
but
turn
she's going
on
to do it
video
on, she's going to do it on the board.
Try
She's going to do it
Try it
on
on
the
the
board.
screen now.
I said try it.
So can you try? Is it possible for you to write on this screen now? I'm not sure.
I don't know.
Try if you
No,
can.
sir.
Try
That's
if you
not
can write. If you
possible.
cannot write, I will just check my control. Wait, just try. Is it possible? Can you write? If you cannot write, just let
No,
me know.
sir. You cannot
It's not
write.
possible it's not possible for you to write like, okay, it's requesting remote control of the screen. Approve. Excellent. Oh yeah. Get off. Oh yeah, right.
So it's not possible.
Sir, I don't know. I can't write on the
Sir,
screen.
it's not possible.
No, I think it's possible. There was you asked for control or something.
Sir, it's not possible.
Yes, sir. So I'm trying to write.
Somebody's
It's not
writing.
working.
Somebody's writing. That's good.
No, right. He's writing now.
Okay, sir, but I cannot erase.
You can't write.
No, I cannot erase.
You cannot erase. Okay, I can help you erase. Let me erase this stuff. Oh, yeah, right. Let's see.
Let's go, motherfucker.
Find your language. We're in a class. Okay, let me just do it. Don't worry. So since we're having difficulties, let's just do. Okay. So what's our rule now? Our rule is what?
Stop.
Good. So the first one we want to show. Oh, sorry.
So n is equal
To show that n equals to
1.
Please mute your screen, guys. Okay, so n equal to 1. This is plus, please. This is not minus, it's plus. So I have 1 on the left-hand side. No, let me, because I need space. So I'm going to write it here. 1 on the left-hand side, okay? Then if I put 1 here, 1 square minus 1. That gives me 2 minus 1, which is equal to 1. That's correct, okay? So the next number 2, we want to assume. Okay? So what will I do? 1 plus 5 plus 9 plus 4k minus 1 equal to 2k squared minus k. Okay? The next thing for us to do now is to do what? Is to show or prove SAP. Okay. But when n equal to k plus 1, what are we expecting to get? When n equal to k plus 1, we're expecting to get something like this: 2k plus 1 squared minus k plus 1.
2k plus 1 square minus k.
This is the goal.
Sir, can you try for n equals to 2?
N equal to 2. N equal to 2 will be 1 plus 5, right?
Yeah.
And that will be 2 raised to power 2 square.
Minus 2.
Minus 2.
And it's 8 minus 2, which is equal to 6. 1 plus 5 is 6.
Yeah.
Okay. Okay, sir.
Yeah.
Thank
Okay.
you.
So now we want to show.
Sir.
Yes, your question.
In the previous one like this, the one where we said where we used 2n minus 1, where we proved that 5 plus 3 plus 5 plus 2n minus 1. The 2n minus 1 was equals to the third term. For example, it was 3, 2n minus 1 was 5. But yes, sir, when we use 4n minus 1 and we use 2, it's not equals to the second term.
So when n is 1.
Yes, sir.
Oh, sorry. This is not 1. I'm sorry. This is 3.
Okay, sir.
Thank you, my friend. You are following.
Hey.
Thank you. The question is not 1, it's 3. I'm sorry. I'm sorry. And that's how you get 5, okay? When is 2? 2 times 4 is 8, minus 3 is 5, okay? You're right.
Yes, sir.
Okay. Okay. So now we want to show it is
Sir.
true for k plus 1. Yes?
I have a question.
Yes, please, your question.
The last time we used n as the last term in the sequence, but now we're using n as the number of time in the sequence. Like, is there any like actual value of
Please
n,
come again
or
with your
n is
question and
dependent on the
Come again with your question and speak clearly. Please come again with your question and speak clearly.
I said last time we
Yes.
used n as the last term in the sequence of the equation.
Yes.
And now we're using n as the number of terms in the equation. Now you said n is equals to 2. Then you just use 2 terms.
No, my
does
friend,
n
this is
depend
my
on
friend. Wait, no, hold on. This is a series. Okay? You can see it's a series. You can see plus, 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 plus. Once it's a series, you have to add up. You have to add up from the beginning to the number of 10.
Okay, sir.
You get that? It's a series. It's not a sequence. It's a series. So you are adding from the beginning to where you are stopping. So it's like you take a sequence first. The sequence will generate the terms for you. The series will now add up to that point. You get what I mean?
Yes, sir. Thank you, sir.
Good. But the right hand side is just a formula that gives you the solution to the addition of the series. Okay. So now we want to show proof that it is true for n equal to k plus 1. So that will be, we want to now show. We want to show that this is the same thing as what?
Sir, plus 1 or plus 3. Sir, this is meant to be 1, because if it is 3, it will be minus 1. For when n is equals to 1.
Sir, is it 4k plus 1
Sir, can
or
you hear me?
Minus 3.
It will be minus, yeah, exactly. It will be minus 1.
Minus 2. Minus 2. Okay.
So it's meant to be 4k minus 2.
Yes. Minus 1.
1 minus 3, that's minus 2.
That's 4k plus 1.
Slow down, slow down.
Doesn't make sense for you.
Sir, the
Okay,
question.
it's correct. It's correct.
Do you understand now? Do you understand now?
Slow down.
So this, look at this. Look at this. This one is n equal to 1. You are adding when n equal to 2. You are adding when n equal to 3, up to when n equal to k. This is the question. Okay? That's the question that came. Okay? Here, you are adding when n equal to 1, when n equal to 2, when n equal to 3, up to when n equal to k plus 1. You see that?
Would I?
Okay? When n equal to k plus 1, that means that at this point, this will be k plus 1, right? That is 4 times k plus 1 minus 3. You see? Expand this. You have 4k plus 4 minus 3. And that gives you 4k plus 1. Is that clear?
Yes.
Okay,
Yes,
so
sir.
this is the same thing as what? 1 plus 5 plus 9 plus, don't forget, the k is hidden before the k plus 1. 4k minus 3, right? Plus 4k
plus 1.
equal to what? So this becomes, we already know this guy. We know this one by our assumption. What's this guy by our assumption? This guy is what?
2k square minus k.
2k
square minus k.
2x square minus 2k.
minus 2.
Minus k.
1 and 4k minus plus 1.
Abby?
Yes.
Right?
Yes, sir.
So what is left now? So this guy is, we want to now write this guy like this. Now this guy you have here is same as what? K plus 1 is common here, right?
Yes.
Yeah.
Yes.
Right? What is left here? 2k plus 1.
2k plus 1.
2k plus 1.
Minus 1. Right?
Yes, sir.
Which is k plus 1 into 2k plus 1 plus 2 minus 1.
Don't be quick.
2k plus 1.
Right? Okay. So we want to do that now.
2k plus
Right?
Yes.
So how do we factorize this guy now? We want to factorize this guy. 2 times 1 is 2. We are looking for two numbers that if we add them, we get 3. And if we multiply them, we get 2. And that's 2 and 1, right?
2 and 1.
2 and 1.
2 and 1.
2k square plus 2k plus 1.
Plus 1.
K. K plus 1, yes. Plus 1.
What's common?
K plus 1 is
K
common.
plus
2k.
That's 2k plus 1. And k plus 1.
So I will take some questions from you. We will watch one video.
I'm lost.
How do you get 2k squared and k plus 4k plus 1?
Could you start from
Number 3 again.
I'm lost.
Number 3 again.
Okay,
Start from number 3 again, please.
Hold on.
From
Let's start
number
from the
3.
beginning.
Please,
Okay,
number
start
3.
from number 1.
Number 3.
Wait, let me start from the beginning.
Number
Let me
1
start
is
from the
okay.
beginning.
Yes, sir.
Number
Thank
1
you,
is
sir.
okay.
From the beginning.
Thank you,
So
sir.
all hands dropped. All hands dropped.
Ew.
Paddy, drop your hand. Okay.
I'm confused though.
No, don't worry. Don't worry. You understand. Don't worry. You understand. Don't worry. It's quite simple. Don't worry. Let's start.
Okay, sir.
You said don't worry, shut up.
You said what? Okay, let me continue. So we want to show for n equal to 1, right? So when n equal to 1 is just this first guy. 1, that's this one, okay? Equal to, check the right hand side. Put 1 here. You have 2 times 1 square minus 1. And that will be equal to what? 2 minus 1 equal to 1. Okay? Now, suppose I want to take the second step. I say 1 plus 5, right? 1 plus 5, right? I take this 2. That means if I substitute 2 in this formula here, I should get the same thing. 1 plus 5 will give me 6. If I put 2 in this formula here, I will get... If I put 2 in that formula here, I will get 8 minus 2.
Minus time.
Okay?
Yes.
Sir.
Yes.
Okay.
8 minus 2 will give me 6.
Okay.
Yes.
Okay? And 1 plus 5 will
Yes,
also,
sir.
1 plus 5 will also give me 6, right?
Yes, sir.
Okay. Now, I want to assume that is true for n equal to k. Okay?
Yes.
So for me to assume n equal to k, I sum from 1 to k. You see? When n equal to 1, n equal to 2, n equal to 3, up to n equal to k. I sum everything. And I assume it is true for n equal to k. That means I'm going to substitute k in the formula here. So this 2n squared becomes 2k squared minus k. Is that correct? Correct.
Yes, sir.
Okay? Now, the next thing I want to do now is that I want to prove that it is true for n equal to k plus 1. Okay? I want to prove that it is true for n equal to k plus 1. Now, I think now I need to make you see my face so that you know the person that is talking. So when school resume, you know the person that is talking. Can you see me?
No.
No.
Not yet, sir.
Why?
No, sir.
Yeah, you cannot see me because I'm sharing. You see me later. Okay. So n equal to 1, n equal to 2, n equal to 3, up to n equal to k plus 1. I want to add all these guys. Okay. And some people ask me how I got 4 into k plus 1 here. Right? That is just making, because I'm adding up to k plus 1. So I have to make n equal to k plus 1 here. So if n equal to k plus 1 here, I will have 4 multiplied by k plus 1 minus 3. And if I expand that, I have 4 times k, which is 4k. 4 times 1 is 4 minus 3, right? 4 minus 3 gives me 1. And this is my 4k. So I have 4k plus 1. So it means I am trying to take the sum of 1 plus 5 plus 9 up to 4k plus 1. What will that give me? I expect that to give me this formula when n equal to k plus 1. When n equal to k plus 1, this formula becomes 2 times k plus 1 square minus k plus 1, right? Which we further simplified into k plus 1 is common here. Put k plus 1 out. What is left if I remove k plus 1 here? A k plus 1 is also left here times this 2. That's this guy. Okay? If I remove k plus 1 from here, what is left will be 1. Okay? Okay? Then I have a k plus 1. If I expand this, what is inside this bracket, 2 times k gives me 2k. 2 times 1 gives me 2, right? Then I subtract 1 from it. Then this simplifies to 1, right? And this 2k is this 2k plus is plus. Okay? Anya, your question quickly before I didn't want to entertain any question, but just quickly.
Yeah, please, number 2. I don't understand number 2.
Number what?
From number 2.
From number 2, okay. I want to assume. Number 2, there's really nothing to do in number 2 is, you're not really doing anything number 2. You just assume that any.
The number 2 is just substitution. You just substitute the
just
value
substitute any equal to k. It's just an assumption.
In the example.
So just assume and substitute n equal to k. That's all.
Sir, number 3.
Start from number 3 again.
Number 1 is where you are doing something. You're just showing that it is true for
please
n equal
start
to
from
1.
number 3 again.
Number 3 is where you have to prove. Okay, so number 3, now that's what I'm doing now. So I want to start again from number 3.
Yeah.
Okay, so 1 plus 5 plus 9 plus dot plus 4k plus. So this 4k plus 1 I have here is not, it's not actually 4k plus 1. It is 4 into k plus 1 minus 3. Because this is where the sum gets to nk plus 1. This nk plus 1 I've written here. N equal to k plus 1 I've written here. You know, I'm just substituting n equal to k plus 1 at n equal to n here to k plus 1. So if I take the expansion of that, this resolves to 4k plus 1 just by an expansion.
Okay.
And that's why I wrote this
So
here.
I want to ask a question.
Yeah, Neoma, ask your question.
Okay. At step 3.
Yes.
Yes, you did 1 plus 5 plus 9 up to 4k plus 1.
Yes.
Now, I just want to confirm. The value you wrote before 4k plus 1, you're trying to get the value that you would get before 4k plus 1 by subtracting 4 from 4k plus 1. See the difference?
You're right.
4, right?
You're right. And that gives me 4k minus 3. That's what the value before it. You're right.
Yeah, okay.
Because you see, the value here, if I add 4, you see, if I add 4 here, I get 5. If I add 4 here, I get this. If I add 4 to this guy, I will get this 4k plus 1. There are so many ways you can do that.
Okay.
It's just the next value. I'm adding 4 to that.
Okay, anyway, shall continue.
Okay? All right.
Excuse me, sir.
Yes.
Sir, please, I have a request.
What's your name? Praise. Who is talking?
Norma.
Norma, yes, Norma.
Sir, I want to ask if you can please go back to that example where we were trying to prove if one expression is divisible by 2. I would like to
wait, so you want to sleep here?
My example, the one before this one.
Yeah, who is doing that?
Let him explain.
Because of you,
I didn't understand that one.
Wait.
But
Because
I
of you, I'm
understand
doing
this
it
one.
again.
Sir, please. Let's listen, sir.
Neoma, don't worry. Because of you, I'm going to do that question again.
I'm
going to do it again. Okay, so let's continue.
Please, let's complete this.
So let's finish this one. So we already know that this guy is 4k plus 1. Somebody already explained that. Just add 4 to get that. Okay, so the number before this is this guy. Okay, so if we add all this guy up to this point, we already know that as 2k plus 2 from here, because we already assumed 2k squared minus k. Okay, so that is this 2k squared minus k we have here, which is the same thing as this guy here. Now this is left. This 4k plus 1 left is this 4k plus 1 we have here. Okay, that's what is left. Okay, so now I'm adding these two together. If I add them together, I will have you said? So I will have 2k squared, which is this 2k squared, minus k plus 4k is 3k. Then remaining 1, which is this one. Okay, so now I factorize. This is just the factorization is what everybody can do. I factorize this to get this, and we were able to show that this guy is also equal to our expected solution. Okay? All right. So let me quickly try to go back to that question of divisible before we call it a day. Okay? Okay, so we want to go back. We want to show that 3 raised to power n minus 1 is divisible by 2. Okay? And we said that a number is divisible by 2 if that number, for example, m, can be expressed as 2 times something. 2 times something. So we say that number is divisible by 2. Okay? So the first thing I want to show that it is true for 1 when n equal to 1. Okay? So 3 raised to power 1 minus 1 is 3 minus 1, which is equal to 2. And you can see that 2 is divisible by 2. We all know that 2 is divisible by 2. Right? Okay. So the third one, sorry, the second one is that I want to assume.
Sir.
Yes. Yes.
Sir,
Yes.
that is, I think that number 4 should have solved the doing solved.
I can't hear you. I can't hear you. I can't hear you. Speak louder.
Sir, I feel the way you solved example 2, if you had solved example 4 that same way, that's been easier for us.
I've been solving everything the same way I'm solving everything. SAP, I'm showing is equal to 1, true for equal to 1. I assume it's equal to, I'm assuming is n equal to k is true, and I'm showing that it's true for k plus 1. It's the same thing I'm doing. I'm not using any other method apart from the same thing. So now I'm assuming now. So if I assume now, I'm assuming that 3k minus 1 is divisible by 2. So it means this 3k minus 1 actually can be expressed as 2 times another number. Okay?
Yes, sir.
Are you with me? So now I want to show.
Yes, sir.
Is there a question or what? Is somebody trying to ask a question? Okay. So now I want to prove that it is true for n equal to k plus 1. What does this mean? It means that I want to show that 3k plus 1 minus 1, right, can be expressed can be expressed like this. That means if I evaluate this guy, can I show that this guy can be expressed like this? Where y is any number, y is any number. Okay? So that's what I want to show now. 3k plus 1 can be written as 3k multiplied by 3. Okay? So this implies that 3k plus 1 minus 1 is the same thing as what? 3k multiplied by 3 minus 1. Because if I do this by indices, right? What's your question?
So I wanted to ask, is m equals to 2n, is it part of the question, or are you implying it because...
Which one? M equals to this
m
one?
Equals, no, in the question you wrote a number is divisible by 2 if...
Yeah, this is the question. The question comes like this. Show that 3 raised to power n minus 1 is divisible by 2. That's the question.
Yes, I'm saying, is it because it's divisible by 2, so you're assuming that m equals is a multiple of 2?
No, I'm not. I don't know it is divisible by 2. The question says I should show. So
okay, I just wanted to know if
the
it was
rule,
part of the question.
Part of the rule to solve it is to assume. Okay?
Yes, sir.
Spirit, you have a question? No question. Okay, right. So now that we already know this, now this 3k, your question will now be, where is this 3k? What's 3k? We don't know 3k, but we can know what 3k is from here because we already established this guy. 3k can be written as what? 2 times that value plus 1. Okay? So I'm going to substitute now. Substitute 3k here. And this will give me what? 2x plus 1 multiplied by 3 minus 1. Okay? And if I expand this, I have 6x plus 3 minus 1. And that gives me what? 6x plus 2. Now the question is, can I express this 6x plus 2 as a multiple of 2? Is it possible? It is possible because I can write it as 3x plus 1.
plus 1.
Please mute your systems, please. And because I have done that, I've been able to express it like this. Then I say it is what? It is divisible.
Okay. So the 3x
We
plus
understand. Sir, give us assignments. Let's
So the
practice.
3x plus the 3x plus 1.
We never understand. We never
So,
Let us say you understand. You go calm down.
so the 3x plus 1 is like is now the number, any number that you are talking about. Okay?
Okay, sir. Okay, thank you so much, sir.
Mohammed. I mean Muhammad.
Assignment, sir. Shade son.
Muhammad.
Assignment. Video. As for who they ask for assignment now, calm down now. I don't think I can.
So now that
I've explained the last they talk about.
So now that I have done this and I've answered all your questions.
Now.
So I can go back to the slide you were before.
So I want to show us a video.
I'm going to share the video.
I didn't say how.
Now hold on. Please, if you need to watch this video again, I think you should subscribe on the YouTube channel that you are using now, right? Subscribe there, and you can always go to watch. Okay, and if I have a class, you can always see my notification.
Sir, you too sabi.
Also, I'm going to stop this class any moment from now, and I'm going to stop by you enjoying. Now, let me first of all. Oh, you can't see my screen. Remember why?
I can see your screen.
So now I am going to end this class by you watching just a
we
video.
can see your face now.
Watch this video. Watch this video. Just watch this
video.
Yeah.
Okay.
This man, the
Can you see my screen?
No, sir.
No, sir.
No, sir.
You can't see.
Okay.
Yes, no, sir. We can't see your screen, sir.
I only see your fine
Yeah, we can see your screen.
Yes, sir. We can see your screen, sir.
Yes, sir. We can see your screen.
Lecturer me.
You guys are making noise now. Keep quiet. You guys should mute yourselves.
My baby. Tell you what's up.
Sir, please, can you mute everybody? Just mute everybody.
Are you
Okay, so this is actually a question on mathematical induction. Can you hear me? A question on mathematical induction, and I'm trying to use this video and these cubes to show you how this thing actually accumulates and how these things are generated. Okay, so I'm going to start the video now, right? So that you can see how this is working. Watch. This is one. This is second step. So you have something like a box. Watch. On the second step, this is the third step, and it folds into a bigger one and goes straight down.
Okay.
It continues like that, you know.
Okay,
How you understand?
Sir, I don't understand you.
The video to inspire you.
Sir, please, why is there a space? Under that green box, there's a space in between.
That should be the -1.
My friend, this space you mean?
Yes, sir.
Yes, sir, that space.
That space is this -1 you have here. You see, every time you take the n factorial, you have a -1 here. You see this -1? This
Okay.
-1.
Yes, sir.
I'm going to play the video again so you understand. Again, you watch from the beginning. So then you see the -1. When this adds to this one, what? You see a -1 here.
Sir, as it is going, help us to pause the video, sir.
So that's the -1. This joins and comes here as a cube. But it adds here and you see a 1. You see a -1 here. You see a -1 here.
Yes, sir.
This one joins again. And by the time it adds straight down, you see a -1. This -1. This one is another -1. And it continues like that, it gets to the end. Okay?
Sir, we understand, sir.
Okay, so I end my class.
Sir, recommend
Sir, can we get some practice questions?
Please, sir.
Sir, sorry, practice. Get the spelling, sir.
Give us questions to practice.
Sir, we gave the slide available.
Assignment.
Guys should shut up now.
What's wrong with this guy that is shouting at
Assignment.
He would give you one.
Come and release your name.
Are you in primary school? Assignment.
I send practice questions and assignments to.
Sorry, sir, we gave the slide available.
Thank you, sir. What assignment?
Okay, so
Assignment.
That guy.
They're just making noise.
These guys are tweaking, walai.
Practice question is over assignment now. What the fuck is that?
check to the chat box. There are questions that I could not answer.
Sir, we slide be available.
I'm going to change slides to
Okay, so end of class.